This is question B3, part 1, power and efficiency. So here we are looking at unit 2. So I've got my mechanics section open in the data booklet. It says a bus is traveling at a constant speed of 6.2 meters per second. This word constant is important. Along a section of road that is inclined at an angle of 6 degrees to the horizontal. Now the constant speed, and because it's going in the same direction, basically means that all the forces that are acting on this bus are in equilibrium, are cancelled out. The net force acting on this bus is zero. It says the bus is represented by a black dot as shown below, this one over here. Draw a labeled sketch to represent the forces acting on the bus. Now I'm actually going to do this on the bus itself because perhaps it'll be easier in that way for me. Now we have obviously the force vertically downwards. It's weight. Don't use the word gravity. Weight is the force due to the action of gravity. And then we have a reaction force which is always at right angles to the surface. So we have a force something like that. That is right angles, so that's your reaction force. And then you've got, obviously something is driving this, there's a force due to the engine that's actually moving this force in that direction, so that's the force due to the engine of the engine, or the driving force. And then you'll have a force in the other direction, and this should be a straight line, and it should be in the exact opposite direction over here. This is your resistive force. Those would be your four forces that are acting on that bus, and obviously you would draw it here in that way. Now, when doing this, it's really important to use a ruler. So each time I didn't use a ruler here, but you must use a ruler. These forces should be in comparison. I mean, actually, there's some. These are the resultant on some of the forces, but these two should be in the opposite direction. The resistive force should be in that direction, and your force of your engine obviously is in that. So make sure it looks like that. Make sure that there's an arrow on the end to show the direction, and the length of the lines indicates the magnitude, how much the force is. Question 2. State the value of the rate of change of momentum of the bus. Now, the rate of change of momentum is given by this formula over here. That's equal to the force. Now, because there is no net force, because we're going at a constant speed, Newton's first and second law, there is no acceleration that is taking place. Therefore, your resultant force is zero, and therefore this would be zero. Your rate of change of momentum is zero, so you'd have meters per second is the negative one. It would be zero. Then we have the next question. It says B, the total output power of the engine is 70 kW, that's kilowatt, 10 to the 3, and the efficiency of the engine is 35%. Calculate the input power. So we would have your input power, your power in, times by 0.35 would equal to 70 kilowatts. 70 times 10 to the 3 watt, like that. And we want to work out this input power, so that input would equal 70 times 10 to the 3 divided by the 0.35, and that value is 200 kilowatt, like that. It then says the mass of the bus is 8.5 times 10 to the 3 kilograms. Determine the rate of increase of gravitational potential energy of the bus. Now we know, if I just draw it over here, we've got this situation over here. It's 6 degrees here. The bus is going like up there at 6.2 meters per second. It therefore is gaining in height. Your your gravitational potential energy, your EP, is given by that formula over here. The EP is equal to mgh. Now they want the rate of increase, so they actually want a per time. So I basically got to work out my vertical component of that velocity. Now this is 6 degrees, so, and this is opposite, so I hope you'll all be okay that the sine of 6 degrees times 6.2 will be actually the velocity in the vertical direction. That will be the distance divided by time going up. So your rate of change here would be your mass, 8.5 times 10 to the 3, that is your mass, times g, which is 9.81, times by your sine of 6 times 6.2 meters per second. So that's going to be given a joules per second value that you're going to get out there, and you get a value of 5.4 times 10 to the 4 watts. Because it's a joule per second, it's a rate of increase. Gravitational potential energy is in G. It's a rate of increase, so it's a joules per second value, which is a watt that you get. Notice here we've got our answer in two significant figures because we have two significant figures here given in our data that has been given in.